We'll be learning about the engine for a new internet. My name is Scott. I also have Meek here, and I'm going to hand it over to Meek now to tell you a bit about ThreeFold.
Thank you, Scott, for this introduction. So what is ThreeFold? ThreeFold is the cloud reinvented. Why? Because it is self-healing and autonomous. The ThreeFold Internet Engine can scale to a planetary level, store data which can never be corrupted or lost, recover from unforeseen events, and provide 100% uptime. Compatible with AI, cloud, Web 2 and Web 3, and edge IT workloads, ThreeFold allows groups of people to co-own and co-fund their IT deployment. ThreeFold's base layer offers ultimate scalability and security, thanks to its thousands of interconnected tree nodes that provide compute, storage, and network resources to users worldwide. What does the future hold for ThreeFold? Well, we can consider four main phases of ThreeFold. Phase 1 was the creation of the technology. Phase 2 was the expansion to more than 50 countries and 30,000 virtual CPUs. For Phase 3, the current phase, it is the expansion phase to 1 million nodes and more. For Phase 4, we aim at millions of nodes deployed on the grid. At this point, we will be a viable alternative to decentralized clouds. What are we technically resolving? The current model can be easily hacked. It is not scalable enough for future demands. It consumes a lot of energy when it could use less. It is susceptible in conflicts. Most current IT systems are too complex and centrally managed, and in general, there is a lack of data sovereignty from individuals to countries. ThreeFold can answer all of those problems. How does it work? Via the Mycelium network, users can access apps hosted on ThreeFold nodes. That's in a nutshell. So, we have the compute and storage aspect, the network connectivity, and the applications aspect. The ThreeFold Autonomous Cloud Engine has the capability to restore the internet to its original purpose. Because we have unlimited collaborations and creativity potential, authentic information sharing without publicity, and thriving ecosystem with an open source and active community. We provide autonomous computing thanks to our stateless operating system, Zero OS, our quantum-safe storage and network technology, and our autonomous management and deployment platforms. This results in self-healing and deterministic deployments. ThreeFold's nodes are literally plug and play. The tree node, powered by ThreeFold Zero OS operating system, allows anyone to earn by providing compute, storage, and network capacity. You basically only need electricity and internet. Plug the tree node into an electrical outlet to provide power, and connect it to the internet to offer compute, storage, and network resources to the world. There is already a lot of stuff built on the grid. Public cloud, private cloud, blockchain as a service, decentralized apps, secure browser, peer-to-peer communication for chat and video conferencing, DevOps tools, infrastructure as code, quantum-safe storage system, and AI workloads. In the future, we see content delivery network solutions, Internet of Things management, content streaming, fraud and security management, and much more. ThreeFold combines the advantages of current protocols and centralized data centers without having any of their downside. ThreeFold offers unlimited number of transactions per second, has a very good response time, is blockchain secure, self-healing, energy efficient, and highly reliable. The ThreeFold Grid is the open source iteration of our technology. You can consult the current stat at stats.grid.tf. The ThreeFold dashboard contains everything you need to deploy workloads on the ThreeFold Grid. You can also manage your node farms, vote on the DAO, and much more.
Thanks so much, Meek. Yeah, so now we'll talk about the compute aspect of how ThreeFold works, and we'll go on also to storage and network aspects, these being the three main components of the computing system. So for compute, we have Zero OS, which is our lightweight, stateless, secure operating system. As Meek mentioned before, Zero OS is an autonomous operating system, which is also self-healing. So this makes it very simple to operate. Zero OS operators or node operators, they just need to take some standard off-the-shelf computer hardware, boot up Zero OS on it, and it will continue to operate independently without intervention, essentially indefinitely. All updates and everything it needs to do to provision workloads for users is handled automatically. So this makes it very simple to deploy, and this is how we're able to deploy capacity anywhere in the world, including inside people's homes, but also inside of data centers and anywhere else. We are compatible with the world in terms of infrastructure as code. So this is how you can create deployments on the ThreeFold network as a user. So as mentioned before, Terraform or OpenTofu are supported, as is Pulumi now, which is not shown here. And then we also have several software development kits in languages like TypeScript and also Golang. And then we have front ends that we develop, such as the dashboard, which we'll be seeing more of later in the demos, that allow anyone to come in a very simple way and create deployments from their browser. But if you are a developer, a sysadmin, or someone that's interested in a lower level way of operating, we have those things available as well. Deployment is done through a smart contract for IT. This involves our ThreeFold blockchain, TF chain. So users who want to provision workloads on the network, they create a contract on the ThreeFold chain that authorizes the billing for their workload. When ZeroS detects this and also receives the workload information from the user, then it creates the workload on their behalf fully autonomously, and the billing proceeds from there from the user's account. And if the user wants to make any changes in the future, such as deprovisioning the workload, then that also has to go through the same process of updating the state on chain. Everything is signed with the user's keys, so this makes the process overall very secure, and it provides a high degree of confidence that the workload that the user requested is actually what's running in the backend, which is something that we call deterministic deployment. All right, now we'll move on to network. When it comes to network, our foremost offering is called the Mycelium network, which is a peer-to-peer mesh network. It connects devices. Any device in the world can connect the Mycelium network. It offers shortest path routing and can also establish new routes if some links somewhere are cut. And this is good for basically every type of connection technology, whether that be wireless, 4G, 5G, fiber, satellite, peer-to-peer meshes, and things like this. It is a very flexible technology that is designed to provide maximum connectivity. And the very cool thing about it is that it enables direct connections, end-to-end connections between every device that is connected. So even devices that are behind firewalls and things like this, they can still connect to each other directly, and all traffic is end-to-end encrypted, so it's also very secure. Using technologies like Mycelium and also our web gateways, we can create self-healing and redundant architectures where there are multiple nodes in the backend that are providing a service, as well as multiple front-end entry points. Those are the gateways shown here. And through the use of DNS, clients can be connected to different gateways, depending on their geographical location, or rerouted in case the gateway goes down. And so this architecture allows for developing highly reliable and self-healing deployments with multiple nodes. All right, now on to storage. In terms of storage, our foremost offering is the quantum safe storage system, which Nick also mentioned before. This is a highly compatible storage engine that is presented as a file system to the user. So this is basically the normal way that we store files typically on a computer. In the backend, it is a peer-to-peer system which can operate on top of the Mycelium network. It stores data in a set of backends. This data is also encrypted when it is stored, which provides high security. The multiple backend system also provides redundancy and consistency. So data is split into multiple pieces, and a subset of those pieces are needed to recover. And we have metadata storage that also ensures that the data that's recreated is in fact the data that was originally stored. And this can also provide self-healing capabilities if some or all of the backends, well, if some backends go down at any given point in time, they can be replaced, and eventually the data can be completely reconstructed on an entirely new set of backends. So there's no ongoing dependence on any of the original backend nodes used for deployment. This is an example of the sort of classic distributed storage architecture where there is replication of data, typically 3 copies. So in this case, we're talking about 4 copies. So in this scenario, you have the ability for any 4 nodes to be unavailable because there are 4 extra copies available, but this means also that you have 400% overhead in terms of the storage cost and the bandwidth. So this is rather inefficient, and if a hacker is able to access one of these copies, then they have all the data. In terms of quantum storage, we can also achieve a scenario where any 4 nodes can go down, but with much less overhead. So here's how the protocol looks at sort of a high level. The end application or the client writes their files to the file system, and in the backend, our storage system takes those files, encrypts them, splits them into chunks, distributes them among the backends, and then when the file is needed later, it can be reconstructed from those backends and decrypted. This can be used as an archive system, as IPFS storage backend system, personal file store, content delivery network, basically any scenario where you would be writing files to a file system on disk, the quantum safe storage system can be plugged in there as an alternative that offers these benefits. All right, and finally about documentation. So if you want to use the ThreeFold network, either to provide capacity as a farmer or to create deployments, you can go to manual.grid.tf, and everything that you need to know mostly is covered there, with new stuff being added all the time. So there's information about the dashboard and other deployment methods such as Plumi, Terraform, OpenTofu, also some tools, command line tools that we have for creating deployments like TF Command and TF Robot, which can be interesting if you are into scripting or need to create large deployments from a template, more or less. And this can be interesting for anyone that's creating applications and maybe wants to do some load testing or simulate sort of larger scale things happening. You can do that with TF Robot, and TF Command is a CLI tool that's great for scripting as well. As I mentioned, we have the software development kits in both TypeScript and Go. So if you're a developer and you want to develop an application that creates deployments or otherwise interacts with the ThreeFold system, you can use these SDKs to do that. You can also create your own applications. We call these FLIS. That's a packaged application that goes on the grid. That can be a dApp or a regular application, whatever you want to build. And those can be also included within the ThreeFold dashboard. You can run your own copy of the dashboard. It allows users to deploy custom applications. So everything that we do is open source and can be modified if you have the skills of interest there. And when it comes time to connect, you can do this over IPv4, IPv6, the Yggdrasil network, which is something similar to Mycelium that kind of inspired us, and also Mycelium. So we have various options for connectivity, and we'll be showing you more about this in the demos as well. We do offer some very nice and convenient ways to connect to web services over the web gateway, which can be really smooth and get you up and running rather quickly. So go check out the manual if you're interested in that. And next up, we'll be showing some demos to give you a taste for what you can do and how it works.
All right, so let's have some fun now. Let's say you want to deploy on the grid. What can you do? Well, let's go on the manual first. If you want to know anything about the dashboard, you can go in the ThreeFold dashboard section, where you can learn about the wallet connector, the ThreeFold Grid, everything how to deploy, then farms and TF chain. Let's say now today we want to deploy an application. We'll start with WordPress. So all the steps to deploy are here. But of course, we say best way to learn is to show by example, right? So dashboard.grid.tf, enter your password. Of course, go and connect your wallet if you don't have one yet. Then deploy, application, WordPress. So you will need to set a proper email. It will be useful to manage your account. Then select domain. You can choose a custom domain if you have one. For now, we'll go with a gateway domain. Then we want to choose a farm. Let's search a node on the free farm. There's enough resource here. Let's go. And then we click deploy. Once your deployment is done, you will see a details window. You can also access the JSON format. So here we can see the email used. You can always access your password. And of course, monitoring tool, if you want to have some more information on your deployment. To access your WordPress website, you can click on visit. Now we see the website has been deployed. And if you want to access the WordPress admin panel, you can go on the admin panel button here. Of course, you will need to set your credentials. If you forgot them, you can go back here, open the show page, and then copy your password. Then you can access the WordPress admin panel. That's about it for the WordPress deployment. It's really simple. As you see, it's more or less one-click deployment. If you want, you can use the IPv4 option, and you can, of course, set a custom domain. As said before, if you need any more information on this, you can simply go to the manual and you can find all the information to deploy and troubleshoot. Once this is done, let's say you want to delete it, simply select it and click delete.
In this demo, I'm going to show you how to deploy some basic HTML content onto the grid as a website with a nice shareable URL that you can use to send this around to friends or maybe to clients to preview to what you're working on, things like that. Now, you can use your own domain if you have one. You can also use a gateway domain provided by one of our farmers. That's a nice feature here. You really don't need any infrastructure of your own to get up and running. You just need some ThreeFold tokens to create the deployment and some content that you want to share. So let's jump into it here. What I've prepared for this demo is a GitHub repository that has a couple of HTML files inside. The tool that I'll be demonstrating that we offer for this purpose is a static site hosting tool that is based on Git. So you need to have your content in a public Git repository for this to work. GitHub is a very popular place to host Git repositories, but it's not the only place, and you could use another one if you prefer. If you're not familiar with Git, it's a great tool that can help, especially with text files, keep track of versions, things like this. But you don't really need to know much about Git to take advantage of this. GitHub makes it very easy, actually, when you create a new repository. You can upload files directly from your machine like this. You don't really need to do anything with Git on the command line or download any software into your machine. If you have some HTML files, you can just create a new Git repository in your free account, upload the files here, and then pick up at this point in the demo. So I'm going to show you quickly. I just have an index.html file. It's very simple. I'm using Pico CSS to give us some nice styling on the site. And aside from that, it's basically just a heading and a bit of text here with a link to the other page, which is an about page. So very simple website. Imagine this is something that we're working on and we want to share our work in progress content. In order to do that, I'm going to come here and copy the HTTPS, get link, and then I'm going to go to the dashboard. This is where we can create deployments, ThreeFold Grid. Let's go ahead and start from the top here. So I've already connected my wallet and I have some TFT in there. I can cover how to do that for the demo. It's all in the manual. buy some TFT and get those in your wallet. Once you've done that, we'll be going here to the applications page today. Most of the things inside applications are projects that are built, they're open source projects that you can just deploy that already would provide their own content, but static website is one that allows us to provide our own content. So when I open this up at the top here, I can write in a name for this deployment. It doesn't really matter, but I will start website demo. Whatever name you put in here will become part of your URL if you are using a gateway URL. So that's something to keep in mind. You might want to give a nice name if you're going to be sharing that link. Next, we'll enter the Git URL. I'm just going to paste in what I copied earlier from GitHub. And just specify the branch. In this case, it's going to be main. We can see branch name here. Just type that in. If you have multiple branches, you could choose among them. And for the HTML directory, we could just leave this blank. We'll check the info here. Directory to be served. If directory is the root, the repository should not be added. So in this case, it's the root, meaning that our index.html is in the first level here. If I had some folders, I could specify from among those folders. The small capacity is fine for our purposes today. And then we need to select a node. There's some automatic ways to select nodes. If you prefer certified capacity, which are some hardware that we as ThreeFold have offered and for sale or certified, sold from our vendors, that can be a nice way to make sure you get a reliable node. We also have the ability to search by region and by country. In this case, I'm going to use manual input to input a node that's in our free farm in Belgium that we operate as ThreeFold. I've done some testing already on this node today, so it's in good shape. And for the domain, if you have your own domain, you'd want to hit the custom domain toggle here, enter your domain that you want to use. This can be a subdomain, so it could be subdomain site.com or something like that. So if you have a domain, you can easily split off as many subdomains as you want. This could be a nice way if you have a main website that's hosted with a hosting service or like a WordPress site, you can use your domain registrar to get a subdomain without needing to interfere with your primary website. That could be nice from a branding perspective if you're sharing things with clients or something like that. Give them a link at a subdomain back to your website. In this case, I'm going to be using one of our gateway domains, also one that we operate here in Belgium, but there's some other available gateways. I'll just say this might be confusing. If you're using a custom domain, you do also need to select a gateway. That's still going to be where your traffic is routed through, but you won't be using the domain that's shown there, only the gateway node itself. All right, with that done, we can go ahead and hit deploy. All right, so now our deployment is completed, and we have to scroll all the way down to the bottom to find our domain here. Go ahead and copy that. Open a new tab, and I can load this up, and now we can see that it has served us the HTML content from that GitHub repository. So I can move it in the browser, I can follow the links, and everything is looking good here. So that's nice, and we can use this same workflow to deploy multiple sites or the same repository or different repositories. They each need their own VM, so that part's not terribly efficient, but this is a nice thing to do for, say, like quick demos, or even if you needed to host some content longer term, this could be a way to do it with your own domain. Let's see what would be the case if we want to do an update. So I come in here to the About page. I left a placeholder to add some content. So here in GitHub, I can edit the file directly, which is nice. And let's just change this to say, I can go ahead directly within GitHub, commit this. Once I do that, it's been updated here, so that's nice. We can work with Git directly in the web interface, but it's not going to update content that we see here. So one thing you could do in this case, it wouldn't be terribly difficult to just create this deployment again, cancel it, and make a new one. But I'm going to show you if you are a bit more technically inclined and not afraid of doing some things in the terminal and using SSH, then we can connect to the VM that is hosting our site and go ahead and pull in those changes manually. So here's a Mycelium network IP address. We talked about Mycelium earlier. This provides us a way to connect to this VM that's very affordable. Again, we didn't have to rent a public IP, which can be expensive these days. So let's go ahead and connect. I'm going to SSH. We're using root in this case to connect to this VM. And once we get in there, I will go ahead and, from previous testing, there's a directory in here called website, and this has our content inside. And all I have to do is get pull, and this will pull in the latest content. So now when I come back here, I can refresh this page, and the content that we added is there now. So once you're finished, of course, we can just cancel this deployment by here and delete, and that will pull it down for us, and then we won't get billed anymore after that. So especially for quick demos and things like this can be a very low cost. I think it will share some static HTML content on the grid in a very fast and convenient way. Hope you enjoyed this demo, and I hope it inspired you. All right, see you on the next one. In this demo, I want to show you how I personally use the ThreeFold network to deploy my own projects. And in this case, I'm going to be showing off a project that I built in the course of my work at ThreeFold, which is a tool to help our node providers understand how the nodes are working and how they're getting paid. But this can really be anything. If you're a developer and you're writing some code, then ThreeFold can almost certainly host it as long as it's running on Linux. And if you're developing for the web, then generally everything can run on Linux. So we're widely compatible, and if you're working on some code, there's a good chance that a workflow like this can also work for you. So let's go ahead and jump into it. Here's my repository on GitHub for my project. It's called Peppermint. It's written in Python using a framework called FastHTML, but again, that's not really important. Whatever programming language framework that you prefer can be deployed into a Linux environment, then it can run on ThreeFold Grid. So I've got some instructions here for how to deploy this. Those are shell commands, so I'll need to get my virtual machine up and running and get connected via SSH. To do that, I'll come back to the dashboard. Again, I've connected my wallet and I've funded with some TFT. In this case, I will be deploying a virtual machine from the Virtual Machines tab. We have both full virtual machines and micro virtual machines. Full virtual machines are more like what you would get from a typical VPS hoster or typical cloud solution. These have a fairly complete set of software, and they also have a kernel that's included in the image, which means that these images are a bit bigger. They generally include systemd and are familiar environments, so you can pretty much reference any guides that you find around the web about how to deploy things onto Linux VMs or Ubuntu in particular. We have Ubuntu images and a few others. Our micro VMs are more like a container. So if you're familiar with Docker, this is something more like a Docker container, but it's still a virtual machine. It has a kernel that's provided by ZeroOS. And these images are generally built using our own init system called zinit instead of systemd. It's a little bit different way of doing things, which has certain advantages and I personally think is nice to work with. So this is what I'll show you today, just to give you a taste of what that looks like. But again, if you deploy a full VM, then you'll be able to reference most materials out there on the web. And we also have in the manual different resources and some case studies and things like that to show you how to work with both types of VMs. All right, so I'll give a name to my VM here. Demo, using Ubuntu 24.04. We have a few other flavors in there that you can choose from. For our purposes today, that will be fine. A small VM is also fine. Showing the network tab here, there's a few different ways that we can connect. This will just be what we're using for SSH. We can also use this there's connectivity for accessing our site, but the main way that I'll be showing how to do that is using a gateway. So that's a convenient and inexpensive option to make if you're developing a site or something that serves HTTP, then that's a convenient and inexpensive way to make that accessible. You can rent an IPv4 address. Those come with a cost, and not every node or farm and ThreeFold network supports that. So there's some other options down below that are all free. IPv6 also comes with some caveats that the node needs to support it and be publicly available. So that won't work for every node, but it can be a nice option for your SSH connection if you have IPv6. These options below are compatible with every node. Multi-network here is referring to Yggdrasil. Mycelium is, of course, our Mycelium network that we discussed before. Today, though, I want to show you WireGuard access. So WireGuard is an industry standard way of creating private networks. It's a very widely supported and stable way to connect to your VM for SSH, and it's supported on all the major operating systems and platforms. So if you're not familiar with WireGuard, you can find resources out there for how to use it. And today I'll be showing you how to do this on the Linux command line, but there's GUI tools that are available for Windows, probably also for Mac OS and Linux as well, I'd imagine. I'll just show you a quick way to connect with the CLI today. All right, so for node selection, again, I'm going to choose node 8, which is one that I've been working with, and I know it's working well. You can use the node selection options here to find a node for you or enter in the node ID that you prefer. Now I will hit deploy. One nice thing about our micro VMs is that, as I said, the images tend to be pretty small, and this means that they deploy quickly. In this case, the dashboard is also going to be finding a suitable gateway node for our WireGuard access. So just like our web gateways, the WireGuard gateway is using one of the gateway nodes and connecting. I should say that our web gateways are also using the same path as this WireGuard access that we use for SSH to be able to connect over one of the gateway nodes to that virtual machine, which can be running anywhere on the network. So this allows us to expose the VM for our private connection over SSH, and also potentially for other things, as I'll show you in a minute. All right, so here's our WireGuard config. I copy that. I'm going to come into my terminal here and I'll do a pat command. This is just a quick and simple way to write this content into the file. Then I can use WireGuard quick. Actually, I need to bring down my old WireGuard network that I was using before. Okay, so that's going to bring down my existing WireGuard network that I had, and then let's go ahead and bring up the new network. All right, now that I've done that, I can copy the WireGuard IP, and I can connect via SSH. So I use root again. And there's strict host key checking enabled, so I need to do SSH keygen. First time that you connect to your VM, this won't happen, but if you're connecting to multiple VMs that use the same WireGuard IP, then it's something that you might run into as well. Just need to clean those out of your known hosts. Okay, so now we're here inside of our VM, and we are ready to run some commands. So I've prepared all of the commands needed to set up a fresh Ubuntu VM here, and then we'll clone the repository, so pull in the code, and then install the Python dependencies. Again, this isn't really important as to the details. Just the important thing here is that you have the steps that you need to be able to prepare a Linux-based environment that can run your code. So if you're working in Go, then maybe all you need to do is pull in a binary that you previously compiled. Working in other languages, you might need to install a runtime, install some packages. I won't cover all the details. I'm doing that here. Okay, so now that installing the necessary Python packages has finished, we can go ahead and start up the web server. So I'm going to skip over, this is how to start the development server, mainly good for local development, local machine. Here's the deployment instructions down below. So I just need to write a little bit of configuration here, and then I'm already within the virtual environment, so I only need to use this command to the web server. So it's going to start up our web server, and now what I can actually do is come back to the dashboard here, copy this WireGuard IP again, and I can already pull up the hosted site here on the WireGuard IP. Of course, that's only possible if I'm connected to the WireGuard network, so this isn't a great way to publish a site, but at least it can show us for testing purposes that the server is up and running. And now that I've done that, I'll show you how we can set up our gateway to be able to host this in a public way. So what I'll do is come over here. I'm going to hit this Manage Domains button, add a new domain. Go ahead and just take out the extras here. We can use custom domains. So if you have your own domain, you can put it in here. In this case, I'll just be using a subdomain from one of the domains provided by our gateway. This port just needs to match the port that we are serving on here. So here I use port 80, which is standard HTTP port, but it can be any port that you want. And you can also use multiple gateways in front of a single VM using different ports in the backend. So it's a nice way if you have multiple projects, they can all run inside the same VM, assuming there's enough capacity for them, and implement multiple gateways. So that can be a nice way to keep your costs down. All right, I'm going to go ahead and add this domain, add this web gateway to connect up to my VM. And this is using the WireGuard network to proxy the traffic. This is working like a reverse proxy. And it's also going to give us a TLS connection, sort of for free here. And we can already get those for free, such as with Let's Encrypt, but I just mean in a very simple and convenient way. So once I've applied this, then it should pop up here in a moment. And I can copy and paste the domain, or I can just press this button and go ahead and open my tab. So we can see that thanks to some demos I was running earlier, we've already joined the dark side of this particular URL, but let's switch that over and we can verify that our application is working. So that's nice. Now, this is okay, but we do have a small issue, which is that the server is just running here in our SSH session, and that's not great for longevity. This will probably stop as soon as this SSH session is disconnected. So let's go ahead and see how to make our server a bit more permanent so that it can survive not only the disconnection of my SSH session, but also the rebooting of this VM or the node that's hosted on, if that were to ever happen, which can happen from time to time if it loses power or something like that. So we want, or if our code were to crash for some reason, we want it to be able to come back up automatically. So like I mentioned before, inside these micro VM images, we have a program called Zenit that is already taking care of some things for us, like running SSH in this case. And Zenit stores its configuration at Zenit. So if we take a look in here, we'll see there's a couple of YAML files. And if we look inside one of these YAML files, such as SSHD, you can see we have a very simple format here for how to specify our service. So this is pretty nice. And what I will do now is I will write the commands that we need to start our server into a script file. So again, I'm just going to write these, use cat to write them into a file. Start.shell. This is in there. Okay, so now we have our script at shell, and if I run that, and we need to provide it with a full path. So let's just do it like this. I will first change directory into root. And so I need to be in the correct directory, and then I should be able to do those commands. Okay, so let's try our script again. Okay, so that started up our web server, so we know that our script works, and now I just need to ask Zenit to run this script. And to do that, I'll make a new Zenit service file, and we'll model it after the SSHD file. So in this case, let's write a file. And for simple services like this, it's enough to just write an exec line, and I'll just put in the same command that I ran before, which is bash root start.shell. Zenit has more capabilities, like we saw in SSHD. There's a line in there that tells it to run after the other. SSH init has already finished, but we don't really need anything fancy in this case. Now what I can do is ask Zenit to start paying attention to this new service file by writing monitor, and now I'll see that our new Peppermint service is running, and I can also check logs like this, and we can see that all the same log messages are showing up here, which gives us a good feeling that this is working. Let's go ahead and just check back at our, oh, that's our WireGuard IP. Let's check back at the web gateway. We could do either one. And this seems to be okay. We are able to continue using our app. And yeah, so with that, we've now deployed the code. We've created a simple service for Zenit to keep our code running in case of reboots or anything like that. And at this point, I can go ahead and disconnect from my SSH session, and my work here is finished. And of course, once you're done with your deployment, you can come back here and delete it if you want to, or you could change the gateway, add a new gateway, whatever you want to do here from the dashboard. And that's it. So that's how you can deploy some code into a fresh virtual machine, set up your environment there, attach a gateway to be able to.
So some of you, as a freelancer, what's the benefits from ThreeFold Grid? So I prepared some answer for that. And we can, first of all, you ask me about technical requirements and just troubleshooting and support. We can send to you our Telegram group in ThreeFold, so you can, if you have any problem or if you have any issue to deploy on the grid, of course you can go there and do it. That's one thing. Another things about the cost. Of course, as a freelancer, you're looking for the good performance things. Let me allow you to talk on that. Yes, Ala, you can open your mic now.
Yes, can you hear me?
Yeah, welcome.
Welcome.
So I received some question about ThreeFold Grid in this session, Ala. So we need you to help me with some answers. Some of the questions is about the cost.
Yes, about the cost of the full platform, yes?
Yeah, like I'm a freelancer. What the difference between the any centralized servers and ThreeFold?
Okay, so our freelance, you mean how much the freelance will cost us in our platform and how
No, no,
much
no.
profit?
What's the benefit for the freelancers? Like, the freelancer maybe pay for AWS or Digital Oceans, so they will pay for threefold now. I believe threefold will be cheaper, 100%, but I don't know
Yes.
how much numbers exactly of it. Just
So,
say about our experience as a metaverse in threefold grid.
since Digital Ocean, I have a comparison between Threefold and our current AWS and Digital Ocean cost. It will. I can give you a percentage. I can't give you exact numbers. So it's more or less than 60% or 50% in some cases. It will cost the freelancers. It will cost us. Any than
They was
this?
asking me about the troubleshooting and maintenance. I told them we will show them we send to them the Telegram group for threefold, and I will take to answer for next one. Okay. They asked me
Yes.
for the code. What is the decentralization benefits? How does decentralized nature of the threefold grid impact the project reliability and performance?
So
So
about the performance, when you have a region-based decentralized servers, it will be near our clients. Okay, so in some countries, our servers cannot be there, and there is a delation between our servers and our clients. In somehow it's okay, but whenever the servers are near our clients, the performance will be much better. Okay, so this is a performance benefit since Threefold have regions that DigitalOcean AWS cannot provide.
the performance and reliability.
Okay. Reliability, I can't now be sure about the reliability, but if we can change our infrastructure to match threefold and somehow I can be sure that it will be more reliable. But for now, we tested just a little bit. Okay, so I can't give you 100% answer.
No worries, no worries. I can take care of like most of the questions is about what the benefit of the freelancer from this decentralization grids, how they can handle some stuff, how can they do some stuff. So I will take care of this answer, Ala. Thank you very much. Okay.
Welcome.
So the decentralization gives freelancer more control and reduce dependency on the corporations and allows them to run projects sustainably without third party. It also ensure fairer resources distribution and a more equitable internet ecosystem. So anyhow, for the freelancers, first of all, you need the better cost, of course. So to deploy in the threefold grid, the cost will be cheaper than others, and it should be more secure. So we will make another session with threefold grid. We received some different questions about how we can collaboration, how the maintenance, the monetization, and the future potential of the threefold grid. This answer we made another session to do it. How can make it? But all of these things, it's from my opinions, it's about ethical impact of the internet now, what happening there. So we need some change, and threefold will be the next change for that. Thank you very much. Thank you very much to be with us today.